Welcome back to DevOps. Next up, we have Sanjin, who is a former computing teacher and an avid fan of Python since 2014. He has a background in developing programming courses and small educational applications for use in schools. As one of the creators of the Victorian Coding Challenge, Sanjin has been building and maintaining a coding competition platform that has hosted quiz-style events, capture the flag challenges, and in 2014, agent-based challenges where students 2024.
Yeah.
Misreading. Agent-based challenges where students program agents to compete in challenges based on game theory. Please welcome Sanjin.
Hello. Is this mic working? Yes, I think so. Works really well. So let me tell you a little bit about the Victorian Coding Challenge. So this is a competition for essentially students that find computing in school a little bit too easy. It is funded by the Victorian Department of Education through the Mathematical Association of Victoria, and over the last 5 years, we've had over 7,000 students participate. It takes place over 2 stages. Stage 1 is an open-ended problem set. Stage 2 is the competition, which is the interesting part, which I'll be talking about. So just a quick show of hands. Put your hand up if you found computing in school some combination of too easy or boring. All right. You guys would have been the audience. You would have been the students participating. So here's the team that makes it all happen. Daniela, who works for the Mathematics Association of Victoria, essentially managed to get the funding, deals with the Department of Education, deals with the schools, a million emails. Nathan and I essentially make the problems and the platform. Over time, I've become more of the platform person. Nathan's become more of a problems person. And along with us, there's been probably about another 7, 8 different volunteers, some of whom I'm going to mention in the talk. So a little bit about the background of the challenge. So the first part is like an open-ended problem set. We're currently up to like 30 plus problems. And the goal here is just to do something that's a little bit more fun and more challenging than school is normally. So 2 examples of problems. One is, it was called I Always Win the Game of NIM. That is a card game. If you do a binary representation of the game state for that game, you could basically win 100% of the time. So this was a fun thing that the students built, basically like a card hustler that they showed to all their friends, a computer that would win 100% of the time in a seemingly fair game. Another challenge, again, this is something that kids would never come across, was like this time capsule problem, where they get given a time capsule that'll like reveal on a certain date, and they can either hack it in various ways. You could break the cryptography. You could study the API code and find a way to like encode the data in a tricky way where you manipulate the timestamp so that it opens early. So these are the type of problems that we put in front of kids. However, when the competition started, it was COVID time. And this was all pitched as a live event, and we couldn't do a live event. So basically, we had to do like a remote thing. So in 2020, we did a combination of recommendation engines, and we gave students the Wikipedia API. And from the get-go, when we got the actual submissions by students, there were about 40 for each year band. We're basically blown away by the quality. Students, we had a team build their own machine learning model that was making quizzes. I mean, we didn't even know how to mark this stuff. Was it on the basis of like the most interesting and the most creative or the most advanced code? So yeah, that was, it was a really, really interesting time going through all those. 2021 was much the same, except worse from our perspective. We had a theme of games. The 7/8s made text-based games, which went really well. 9/10s, this is my total mess up. We chose to use a 3D game engine in Python that had too high system requirements. Given that I was the one testing it on my computer and laptop, somehow even the school gave me a very nice laptop and my students a very nice laptop. It never really occurred to me that the requirements were too high. We ended up only having 5 submissions for 9/10. So this is the 3rd year of the project. So we had a 3-year grant. And the department essentially is telling us, hey, this year you get to do the live event. We're going to poll the students and the teachers, make sure you give us feedback, and based on that feedback, we're going to decide whether we're going to renew your grant. So really, we were in need of a spectacle here. And here, I have another question for the audience. Show of hands if you know what a CTF is. Okay, leave your hand up maybe if you've participated in one. Okay, maybe I'll do a little bit of explaining. So in this particular class, so I was a teacher that year. I was teaching at the King David School. We were learning networking. And that year, the theme of the class was CTF. So we essentially did challenges from something called Pico CTF. And I basically took part in creating problems and little puzzles for students that they would solve by SSHing into my computer on our local network. If you see there's like a switch in the middle, everybody would come in with a school-issued old teacher computer that had Ubuntu on it, or a Raspberry Pi. And the students themselves came up with this scoreboard, this live interactive scoreboard, where they took those problems and they scored themselves, and they had like live rankings. And this was done, by the way, like halfway through the semester. So we spent like, I don't know, 10, 15 lessons every year, every class students rushing in and then like doing problems and having these rankings on a scoreboard. So for me, I've never seen more enthusiasm in a classroom in my entire life, and this was the idea that I wanted to port to the Victorian Coding Challenge. The first thing that I did was rewrote the scoreboard program. The initial thing that, when you have very enthusiastic year nines that have a lot of talent but not a lot of experience, it was like one function with 20 parameters and God knows how many globals. I turned it into something really simple. One worrying thing, because I wanted to keep the coding basic so all my students could understand it, was that JSON file. Like there was no database. There was just like whole game state was one JSON file, and I was like thinking that's a ticking time bomb that never somehow went off. So yeah, we used this for at least 10 lessons, and it worked perfectly. So if it ain't broke, don't fix it. This is more or less the program I was going to take to the Victorian Coding Challenge. In terms of the challenges, really there were only 3 types. One was they would download a file and they need to solve something. Maybe it was like a password-protected Word file that they needed to find a tool to crack. Maybe it was some encoded or encrypted data. It could have been like a zip file with like a folder jungle where something was hidden that they had to find. Another type was that they would SSH into a Python script. So you create a user on Linux, and then like you create a rule in sshd-config, and then they SSH into like a puzzle you created. They don't see the source code. They're just like inside your sort of text loop. And the last one was a little bit more elaborate. Have you, show of hands, if you know what a root jail is? So like you create essentially like not really a virtual environment, but like a folder with all of the necessary tools and libraries to have a very restricted like Linux system. And in there, they perform a task. So those were the 3 types of challenges. And in terms of how this was deployed, now this is terrible. I mean, people talk about like being embarrassed by past code, like, wait for this. So 3 Python files that do the admin easy. So each challenge was actually, the users didn't have accounts. Each challenge was a user. So they would SSH into that user. You could have multiple SSH sessions for the same user from different IPs. Linux is flexible like that. They would go in and try to get a flag. Then there would be another user called a scoreboard. They would SSH into that to submit their flag along with their password, and they would get their scores updated. So that's how it worked. And with 9 students in my class, it never broke. Now, I did take a look at other projects that did similar stuff, and they were about at least an order of magnitude more complicated. And I was wondering, like, this is so easy. I don't know why do people make it complicated. So in terms of the user interface, it was very basic. Google site, you can host files there. You get the instructions to the SSH. And then like the challenge went for 3 hours. Every hour we released new problems and new challenges. So this is the competition day. And let's see how we're going. So in the morning, there's something called relays, like unplugged problems. The kids smashed that. Everybody had a good time. At 11 o'clock, I'm standing in front of a crowd about 3 times the size going, we're going to do a systems check. Everybody has a flag. It's there. It's on paper. You're just going to type in this into your terminal, submit, and we're all going to be good. Turns out, works for about 2/3 of the teams. And then all of a sudden, a bunch of people can't submit it. And I have no idea why. Luckily, this is deployed in a Linode server that takes less than 90 seconds to restart. And so restarting, it fixes the problem. And that was my day. Like, this is a student there looking at me. I'm probably restarting the Linode server right there, and everything somehow just rolls over the line. Until about 10 minutes to go, where I mentioned root jails. They are escapable. The score of the top team, which was winning by a country mile, I mean, like they probably risked disqualification, but I was really impressed, just went up by 3 zeros. And then it went down back to normal. So yeah, I really, when this all ended, I was almost shaking. I really didn't even know how we went, but was the funding lost? No, we were good. So despite all these technical issues, every team submitted everything they found in terms of the flags. The feedback from students was amazing. And the teachers did mention some technical glitches, but they were happy to. And like, not only did we get our funding renewed, like we actually got way more funding. So this whole thing ended up being, thank you, ended up being a big success. The tech postmortem. Now this is the if it ain't broke, don't fix it 9-student thing. If you open up the SSHD config of any Linux system, you're gonna find commented out the default settings. And I only would have needed to change that max sessions from 10 to something like 30. That wouldn't have fully fixed it because there was another problem where students used like these terminals that were in the browser. And if you close the browser, you don't close the session. So that was a major issue. Another thing that could have been a potential issue was there was a challenge that was around cracking a hash. But they had to enter a password into an SSH, and a team tried to brute force that. So I don't know if this max startups thing, that sort of limits the amount of waiting connections to 10 and then drops 30% after 10 kicked in or not. But yeah, the part that keeps blowing my mind again and again and again is that not having a database wasn't the issue. That single JSON file that was edited just somehow worked. Yeah, the Megascore kid, I had a really good conversation with him. He actually learned that on the spot. Like, nobody finished except that one team. And he had enough time to read a blog about escaping root jails and apply all of that. So that was impressive. Lessons learned. If it ain't broke, try your best to break it. Like, that's just, I had that attitude of like, this works in all the circumstances I tried it, but you can actually quite easily simulate more terrible circumstances. For me, personally, the mix of technical failure and the student enthusiasm, like I've never been more motivated than at the end of this to try to work and try to make this a much better platform. So that was the perfect thing. And yeah, in the space of 2 weeks, I had 2 babies. A human one, my daughter was born about a week before the challenge, and then after all this happened, the project became something I started to take, very, very personally and seriously. So where to next? More funding allowed me to step away from mostly making problems and worrying about the platform. Now, funnily enough, the first thing I did after this broke is I spent all of my free time in the next 2 months rebuilding the CTF platform, which never got reused. Because we ended up deciding that we're going to step away from the CTF thing, and we're going to try to build a platform that was more like Google Quizzes, so where we could ask different types of questions, except that it would incorporate a live scoreboard, because the live scoreboard was the pretty big deal there. So yeah, that was my job to build it. And this is the tool set that I chose based on the situation, based on like a mixture of what looked interesting to me and what looked not intimidating to me. So I did teach, normal CSS, JavaScript, HTML, so it was just vanilla JS on the front end initially. SQLite, given that it works seamlessly with Python, was going to be the choice for the DB. FastAPI. Now, I had some familiarity with both Django and Flask before FastAPI, but that FastAPI seemed easy and obvious from the moment I first looked at the documentation, so that was going to be my back end. And I was going to do the serious developer thing with GitHub, automated deployment, automated testing for every commit, and so on. And going to use AWS for the first time. Now, I only use more or less these apps, but I get billed for other apps. I don't know if other people have similar issues with AWS, but it's really annoying. So I don't have that much time for technical detail, but this is more or less how I ended up slowly building a more robust platform. So by April in 2023, I had a prototype that just worked. It had all the features that we needed. Students could do short answer questions, multiple choice. Like I used all of the libraries I wanted, and it was deploying automatically, so that was pretty good. By September, I had added an admin page, which made it easy for us to populate questions. There's also a junior day for years 5, 6 that I was very little involved in, but I made it easy for those guys to just create questions and put them on the site. And by October, with about a couple weeks to go, I had gone to town with testing. I used something called, show of hands if you've heard of Locus. I have no idea if this is popular. It does stress testing. Basically, there was local testing, there was stress testing, and I found every excuse I could to get every circle of friends, every professional group to try to use the platform in some other version. I dressed it up as AI trivia. Look, AI is making these JSON files, which are trivia, which was just an excuse to test my platform. So basically, after about 3, 4 successes, like I decided to let it go. There were a couple of weeks left. This is Locus, by the way. That was a screenshot in the WhatsApp group. I was running about 142 requests per second. I expect the competition only needed about 5, so I was like safe in that regard. This is what the competition looked like. These are groups of questions. This is actually a primary question, and this is going to be either like multiple choice or a short answer. They have 3 attempts at the short answer. There's going to be scoreboards. You're going to see them on the pictures. And so, yeah, a couple of weeks to go. And I have an idea that I've been thinking about a long, long time. And it is the idea for like an agent competition. And the idea here is like, imagine some simple game, and the students would program an agent to play that game. And the agents would compete against other agents, and then they would get some feedback, and then they would try to like adjust strategies. So, you know, this is a bit of a technical challenge, but I thought that in the 2 weeks I could do like a 10-minute preview and show it to the students like this is what we're going to do next year. So, yeah. Like I said, I only wanted a 10-minute demo. I mean, again, student code running on my server. This is a bit of a challenge. But here's what happened. In one day messing around with ChatGPT, I had a proof of concept. And all of the sort of big challenges I thought I had, which was like making sure that the student code is properly formatted and you know, I don't have random silly indentation errors and syntax errors, was sorted by something called inspectlib. And it was converted to like a playable game object using something called importlib.util. And so within one day, I started thinking, well, maybe I could do a little bit more than a 10-minute preview. I mean, I know it's really risky, but we're going to cage it in, you know, this is experimental, might not work. So we basically decided, I somehow convinced everybody else that we should do a 45-minute mini game with the students. And it'll be worth 5%. Not a lot of consequence. And the student experience was really, really easy. So they played a game called Greedy Pig. And Greedy Pig is a bit like blackjack in that there's a dice rolled. You keep adding to your total unless the dice rolls 1. So it's about kind of like knowing when to stop. And there is a statistically correct point to stop. But if you have a game state where you know where the other players are doing, you can do a much more sophisticated strategy. So this is like, they got a REPL on a website called REPLit. They had a working player with a working strategy. And all they had to do was tweak that in 45 minutes. They had, you know, we had acted out a game in front of them with 10 minutes. They were told what the game was a week in advance. And interestingly enough, a lot of primary students in Australia play this math game in class. So yeah, like from the student point of view, we knew we were good. We knew that like they could understand it and play the game. Okay. So yeah, like essentially from the student point of view, a couple of if statements, if they understand the game, they could implement a very good strategy. So the live event in 2023, going back to that live platform I built with FastAPI, SQLite. That all worked perfectly. It was tested to the max, and the only bug we had was in the competition, teams would log in with 2 laptops to the same account. And the scores were added up on the front end, not the back end. And so they all had wrong scores because they were logged in with 2 computers. Other than that, having to tell them what the scores were, we didn't really have any bugs. So with an hour ago, it was all smiles. So now the 7-8 day and the 9-10 day, they're about a week apart. So with the 7-8 day, I set the expectations. Guys, this agent games thing we're about to do is an experiment. It'll probably not work. Da-da-da-da-da-da-da. But let's give it a try. This is what we're going to do next year. It's a really cool concept. And it worked, other than like the server was overloaded with submissions and it crashed a couple times. So I've fixed that over the week for the 9-10s. I got this slow API rate limiter that only allowed one IP to do 3 requests a minute. And I also added all these security features, forbidding certain libraries and certain functions. And so for 9-10s, I was confident. And the speech wasn't, this is just experimental, probably not going to work. Guys, you're going to love it. The 7-8s loved it. And here's what happened. That remote address in a venue, which was the library of the docs, somehow every single IP in the building, every single computer in the building had the same IP. So instead of limiting one team to 3 submissions a minute, we limited all the teams to 3 submissions a minute. And it was like a car crash in slow motion, because it's not like totally failing. One team got in, but we're running out of time. And so we ran out of time, and it was really, really, really frustrating. But yeah, still, the feedback of that was, I really want to do agent games. I really wish that worked. So like I was fully committed to doing agent games right. So this is very much exactly the same thing that happened with the year before, except this time I'm going to make it an open source project. I'm going to try to get other people involved. The quiz was staying. That was all fine. I have another kid, and the history repeats itself. So making agent games bulletproof, having student submissions run on my own server. The key here was a mix of validation, which used all of those things. I realized I'm running out of time really quickly. But most importantly, every simulation only ever ran in a Docker container. And if your code was overly analytical, overly slow, it was rejected. If it managed a simulation against a bunch of dummy teams in under 3 seconds, your file was saved on our server, and we were going to simulate you, and that was all going to run. So this is what the backend looked like when we run a simulation. Students and us, we get to see this feedback in PDF, that they get to see how they did against other teams and adjust their strategy based on that feedback. In terms of the platform, the coolest thing that I did was I made the game itself really kind of extensible. It only takes about 2 to 4 hours to make a new game. By the way, I'll be here for the developer sprints, and if anybody's got cool game ideas, I would love to hear them. I'm going to have to skip a whole bunch of slides, but I'll definitely show you this one. The agent games. The event went really well, but first we had prelims. And in the prelims, we had about 700 submissions and several successful hacks and teams just beating everybody with a 100% score. The most interesting of which was the one on the screen there. A kid figured out that we're using the random library. He then found a way to brute force random so that every single time, for every single thing he did, the dice rolled a 6. And so even after 1,000 simulations, like he stops at 100. He stops when he wins. He like doesn't, because he only gets 6s. It was like the most genius thing I've ever seen. So yeah, I mean, I'm going to fast forward. The competition went well. We had one funny bug. We had a mystery team appear. Now, I checked all the server logs. Nobody logged into the server. I was really paranoid. What had happened is because I'd outsourced my vanilla.js front end to a freelancer who did it in React, He was kind enough to put a sign-up button there. And that was the only security breach we had. Thanks to GitHub automated deployments, I got rid of that in about a minute. But I was really sweating for about an hour. A couple of nice things to say about people I helped. This was the freelancer Mohammed. He wrote the front end. Matthew there, who is a master's student, helped me with the Docker. Han, who is the head shooter of the first year subject in Uni of Melbourne, did a whole lot of testing and made the agents more secure. And Nathan made the markdown feedback. And this is the repo. And in the future, I plan to try to share this with unis, institutions, schools, other competitions. Yeah, and thank you very much. I had a lot of fun. For the platform, if you can help out with any of these, Docker performance improvements, deployment on Windows. I hate Windows. I wish this thing could just work on Windows. So if somebody can do that, that would be nice. The feedback tends to be too long. We need to make that markdown searchable. So yeah, those are some of the issues that I'm about to document nicely on the repo. And yeah, that's everything. Thank you very much.